I was just yelling at my dog because I just walked in and my cursor was on the floor, chewed up.
Uh-oh.
Luckily it still works, but gosh, I don't know how. It is a mess. So,
Right,
what do we got tonight? You got your final tomorrow?
yeah.
Okay.
So I have a review sheet today.
Okay.
And I wanted to go over and review. So okay. It wants us to know to determine the exact value of 2 tangent 75 degrees of the 2 times tangent 75 degrees over 1 minus the tangent squared of 75 degrees.
Well, how can we do this one?
You can use the sum and difference formulas.
We could use sum and difference. We could also use the half angle formula. In other words, tangent of 75 is equal to the tangent of 150 over 2.
Okay.
Which one would you prefer to use? Actually, the sum and difference one might work a little better because then it comes out very close to this. What's the sum?
All right.
What's the sum and difference formula for tan?
It is A or tangent alpha A.
Tangent A times tangent B.
Or plus tangent B.
Plus
over yeah.
1 minus tangent A times tangent B?
Mm-hmm.
Okay. So, I've got, well, I guess I can just go through and plug in everything, huh? I know what the tangent of 30 and 45 degrees are, so I'll call A 30, B 45. So let's just plug in. 2 times tan of 75 is this. So we'll have the tan of 30 plus the tan of 45 all over 1 minus the tan of 30 times tan of 45, all divided by 1 minus this whole thing squared. Let's just write it like this. Right?
Yeah.
So is this anything more than just a complex algebra problem?
Nope, not really.
You want to take it further?
Yeah, maybe.
Okay. What's the tangent? Remember, A is 30, so let's start substituting. So I'll write it over here. We got 2 times
root 3 over 3.
Plus tan of 45.
Yeah, which is 1 over 1 minus.
Divided by 1 minus root 3 over 3 times 1. So that's the numerator. And the denominator is 1 minus this whole numerator squared. So,
wait. Which whole numerator squared? Oh, that one. Okay.
This one right here.
Yeah.
which is this numerator. So let's see, we have square root of 3 over 3 plus 1, all divided by 1 minus square root of 3 over 3, and this whole thing is squared. No, it is. Yes. The bottom is 1 minus, oh yeah, this thing right here is what was equal to this. Okay? So,
Okay.
now I just have to reduce that thing. Well, let's have a look at it. Let's see. Let's erase everything we don't need. Seeing if there's any way I can simplify it, because I have this term squared here and I have that term unsquared there. Well, the worst case scenario is I'll simplify it. Let's multiply the 2, so we have 2/3 root 3 plus 2 over 1 minus that is 2/3 that. In other words, this would be 3 over 3. Oh, what am I doing? Excuse me. Hold on. It's 3 minus root 3 over 3. So far, so good. In fact, let's extend this line here and call that a 6. Because now I have the same denominator, 3, in both top and bottom. In fact, I could cross those 3's out. But before we do that, wow.
Yeah, I don't know.
Well, let me see if I can figure out how to simplify this. This is 2 times x, or that's x, all over 1 minus x squared. I don't see any way to simplify that. Well, it's 1 minus x times 1 plus x. Well, it's doable. It's just a pain. In other words, all right, let's square this. If I square the top, I get 3 over 9 plus 2 times root 3 over 3 plus 1. That's this numerator squared. And then let's square the denominator. I get 1 minus 2 root 3 over 3 plus 3/9. So, as difficult as the algebra is, we got it all down to numbers. I can take these 3's out. So my new numerator is 2 root 3 plus 6 over 3 minus root 3. Oh man, this thing just gets crazier and crazier. Aha! The bottom. This becomes 1 1/3 plus this divided by 1 1/3 minus that. So let me erase everything I have over here and see if I can rewrite this thing as we whittle it down. So we've got let's see, the numerator is this. There might be an easier way to do this and I'm just not seeing it, but not sure what their purpose of doing this to you was. You still there? Did I lose you for a while?
I think so, but it's back.
Yeah, I heard it come back. I never know when it disappears, so I'm not sure how much of what I'm saying you're getting.
I can hear you. I don't know if it could hear me.
Okay, you with me?
Yeah.
Well, 1, I can make this. 1 I can turn into 4/3. I haven't had an algebra problem this hard in 6 years. Minus 2/3 root 3 all over that same thing. There's my 1. And now I can operate on the bottom because they have a common denominator. And notice that disappears and this disappears. So that bottom becomes, yikes, 0.
Okay.
That doesn't work. You can't divide by 0.
Yeah, no, I don't know, because it has a bunch of answers, like it's multiple choice, the worksheet. I can't figure out how to do the problem. I don't know.
No, maybe a better way to do this would have been to use not the sum and difference, but the half angle. I certainly could have done it using a half angle, and the arithmetic might have been a little easier. It's not easy doing the algebra when you have a combination of rational and irrational numbers, as you can see from my attempts here. And gosh, I got undefined. What was the original problem? What was the tangent of tangent of 75 degrees?
Yep, over 1 minus tangent squared to 75. I don't even know how you go around solving this. So the answers they have at the bottom are... Actually, wait, I have the answer in my sheet somewhere. I just don't have how to get the answer.
Yeah, no, I get it.
Answer?
Yeah, it's easy enough to get the answer with a calculator.
Yeah, it says that the answer should be negative root 3 over 3. I just don't know how that's a thing.
Well,
could you separate out the tangent squares? Like, could you do 1 minus tangent 75 times tangent 75?
Yeah, you could. But that's how I ended up getting this super complicated fraction over here in the circle. As I multiplied the formula for tangent of 75 times itself. I'm not sure I know an easy way to do this. If you gave me enough time, I could probably whittle this thing all the way down. Although, I must have made a mistake here because this numerator means 0, and that makes the denominator 0, which means we're dividing by 0. That's a bad thing. You tell me. We can spend the next 15 minutes on figuring out this problem or doing another problem.
Let's move on.
I think it's best to move on too, just because this is like unscrambling a roll of string that's all tangled up.
Yeah.
We know how to do it, but solving that algebra is really tough.
Yeah. Can we go over... I don't have any problems like it on tonight's homework, but... Sorry, I have to go through my stuff. The solving for like a variable over something. Like, oh, here we go. So it wants you to solve 2 sine squared x minus sine x minus 1 equals 0 over 0, comma 2 pi.
Okay. What are we looking at here?
Well, you have to simplify it, right?
The quadratic.
Yeah.
So let's factor it. That's the way we solve quadratics. What goes here? What goes here?
So you would have sine x and then minus.
Hold on. What goes here?
All 2 sine x?
It's got to multiply to this.
Yeah.
That's the rule. So it can't be just sine x. It's got to be, now this times that is equal to that. Okay, what are my signs?
Negative and positive.
They're opposite. But I don't know if they're negative and positive. They might be positive and negative, and they're different. In other words, each of these would be a different answer. As long as these coefficients are different, you can't just write plus minus and have it mean the same as minus plus. Okay? But the rest of it's pretty easy because there's only one factor of 1. So let's just try it. Does that produce the right answer in the middle? In other words, does that produce a correct middle term?
You have to have a negative 1 in the first parenthesis.
Okay. So the way I test it is I do the inside multiplication, I do the outside multiplication, and I add them together. That indeed gives you a negative sine x in the middle. So that is the correct factoring. Sine x minus 1 times 2 sine x plus 1. Now let's solve for first sine x, and then let's solve for x. So what's 1 sine x equal to?
Okay, so 1 sine x would be equal to negative 1?
Positive 1. In other words,
oh, yeah.
set that equal to 0. Okay. In the unit circle, that is from 0 to 2 pi, where is sine x equal to 1? What value of x?
90 degrees?
Pi over 2, or 90. That's the only place. In other words, if I draw one period of my sine, there's only one spot that it's equal to 1 at pi over 2. Typically, there's 2 quadrants that answer these, but not when you have your quadrangles. Sometimes there's only one. And then the other part of the equation is 2 sine x plus 1 equals 0. So what's sine x equal to here?
Negative 1/2.
And which 2 quadrants does that happen?
That happens in the 3rd and 4th quadrant.
Okay. What's the angle? What's the reference angle we're talking about?
40, or not 45, 30 degrees.
Okay. So what is the equivalent angle to 30 degrees in the 3rd and 4th?
Wait, so in the 3rd and 4th it would be negative 30? No. Because you have to go around.
Right. Well, I've got some angle where this is equal to 30 degrees. What's that angle?
That would be, wait, because it wants it at 0, comma pi over 2. I don't know what that means. It says,
Well, this is a 210 degree angle.
So, yeah, but when it says it wants it in pi, how do I do that?
Wants it in radians?
Yeah.
Okay.
Sorry.
Well, 210 is 180 plus 30. 180 is pi, 30 is pi over 6. Add those two together, you get 7 pi over 6. So 7 pi over 6 is the 3rd quadrant angle. Now we're looking for a 4th quadrant angle where this is 30 degrees. What's that In degrees.
In degrees, it would be 330.
Okay. Which is a pi over 6 short of 2 pi, right? In other words, the whole unit circle is 2 pi. 30 is pi over 6. 11 pi over 6 is pi over 6 short of 2 pi. That's kind of just the way I do it in my head. Is the way I think about it. In other words, you can find a common denominator and do that. That's 12 pi over 6. 12 pi over 6 minus pi over 6 is 11 pi over 6. So this has 3 answers. Pi over 2, 7 pi over 6, and 11 pi over 6. Every one of those answers satisfies this equation.
Okay, and aren't there cases where it's the answer doesn't work?
Yeah.
You have to go and check it?
Well, I'll give you one. Solve that. Factor it.
Minus 2. So, sine and sine. Yeah.
Now, when we go to solve it, we got sine x equals 2. Well, that's impossible. The range of the sine function is minus 1 to plus 1. Anything outside of that can't be. So the only solution to this one would come from this. I would cross that one out. That is an extraneous solution.
Okay. All right. Cool. What's exact values? That's easy. Can we do a simplify one and then?
Sure.
Okay.
Do it.
So wants to simplify the cotangent of theta over 1 minus cosecant theta.
Well, I can turn both of these into sines and cosines. And that probably is the way to go. So let's do it. What's cotangent? In terms of sine and cosine?
It's cosine over sine.
Cosine over sine.
Mm-hmm.
Okay, and cosecant is?
1 over sine.
Okay. Now let's find a common denominator in the bottom.
So you would have to multiply both by sine over sine.
Okay, so I got cosine over sine all over sine minus 1 over sine. Right?
Yeah.
Well, now I can cross the signs out, and my answer is cosine over sine minus 1. You think about that for a moment. Do you have answers?
Not how to do it, just like what the answer should be. The answer to this one is secant squared theta plus cosine squared theta.
Secant squared theta plus cosine squared theta? How is that simpler than this or this? Okay, well, there's more than one way to skin this cat. Secant squared theta. Well, I can get that probably by turning the cotangent into tangent. see. I multiply the bottom by the conjugate. I'm going to end up with 1 minus cosecant squared of theta, but that isn't equal to anything. Is it? Let's see. Cotangent squared plus 1 equals cosecant squared. So, yeah, 1 minus cosecant would be minus cotangent. 1 minus cosecant squared would be minus cotangent. So, I do get somewhere by multiplying this by the conjugate. Let's see what happens if we do this. So this produces in the numerator cotangent times 1 plus cosecant, and in the denominator 1 minus cosecant squared, which is negative cotangent squared. Now I can cancel that with that. What was the answer? Secant squared plus cosine squared?
Yeah, it was another one of the ones I couldn't get. I don't know if I do it. It's just weird.
I'm thinking here. So basically this is an identity. In other words, we're trying to prove the identity. Well, let's start there. Maybe it'll be easier if I'm looking at it like this. So, let's see. Well, I can turn that into sines and cosines. That's already in cosine. If I proceed with my original plan, which is to turn this all into sines and cosines, I should get to this. I can rewrite this one as 1 over cosine squared plus cosine squared. So let's see, again this was cosine over sine, all divided by 1 minus 1 over sine, which is sine minus 1 over sine.
Could you... I don't even know.
I'm stuck. I'm not sure. These can be really tricky. Some of these verifyings are so hard that if you start off on the wrong path, you just end up lost in the trees. And then
Yeah, my final tomorrow is multiple choice, thankfully. So.
what's that? Well, that doesn't make it easier. That actually makes it a lot harder.
Multiple guess.
Because at least this one, we know what we're trying to prove. We're trying to prove it equals this. If you gave me 5 multiple choices, I'd really be lost. Because I wouldn't know which one to try to prove.
Yeah, I don't know.
Well, I hate to leave you with something unsolved, but...
That's no problem. I can go talk to my math teacher tomorrow morning.
Let me think just a second before I leave you. Secant squared is 1 plus tangent. So if I work with the right side, which is certainly permissible, then cosine squared is tangent squared times sine squared, isn't it? Let's see. Sine squared over cosine squared equals tangent squared. So cosine squared is sine squared divided by tangent squared. So I could do this. Now, how is that on the right equal to that on the left?
That is the question.
Mm-hmm. I don't know, and unfortunately I don't have time to work on it. Unfortunately I'm working till like 9 tonight, so it's not like I'm going to have time to look at this later. If I come upon I don't know, it'd be too late to contact you, so I don't know what to do. I guess I'm going to have to leave it unsolved.
No problem.
Much as I hate doing that, because I love these. I love these trig verifyings. I'm usually so good at it, I don't know why I can't think of how to do this one. But I can't.
Well, thank you.
All right, Sarah. Good luck on your test. I hope you don't have this one on there.
Yeah, me too.
All right.
All right.
Talk to you
Have a good night.
after the break. Okay.
Bye.
Bye-bye.